right, everybody. Good evening for those who are on the East Coast. Good afternoon for those on the West. I may be somebody here from around across the world, so good morning to you. My name is Raul Singh. I am the principal platform architect here at Anant, and we are going to talk about building a REST API with Cassandra on DataStax Astra using Python and Node. The whole premise of this presentation is to show how easy it is for people to get started with Cassandra and Node or any programming language. As we iterate on this deck, we'll add more code samples and maybe even go definitely Java and Scala. What is for us today? Well, we want to talk a bit about applications and give you a context for a real-life application that we use every day, and we actually leverage it to publish websites, but also just to manage knowledge. And our transition from servers and virtual machines to becoming more container-oriented or serverless, and give a glimpse into the future of what is to come with functions as a service, where we are planning on doing that. It's not something you're going to see today, but in a later iteration of this presentation, you will. Why are we going in this direction? And going serverless is not just a conversation about managed databases or functions. It's a paradigm shift for engineering teams, product management teams, to think about the platform or sets of platforms as something that somebody else manages for you. Of course, the reason is why is to save time. We're also going to be using serverless platforms to do development. Last time I gave this talk, which was last week, I was using my tablet to give a presentation, and I was showing how to run Python APIs, and everything was done through a web browser. So it's something we want to showcase to you. You've probably seen it in a few places. And by the way, this presentation we're going to give again and again and again as we continue to develop this software. And our goal is to make it easy for you to use Cassandra. As a company, we build real-time business platforms. And what that means is we connect real-time customer experiences, whether it's an app or a website, or nowadays devices that are sitting in your home, with information systems on data and analytics platforms. And information systems being the systems that support the company to deliver value or to run the company itself. And a distinction for us is we focus on fast data and analytics platforms, meaning real-time, event-based. Getting right into it, what is Leaves? Leaves is a knowledge base UI and API that we have been working on. It's something that we started about, actually I would say it had a longer history than a few years ago, but it started off with just a basic desire for me to share lists of links. Whenever somebody asks me a question, so Google that, go to this link, and there are other software that do this, but my goal was really to save links, kind of like a bookmark, categorize them, and give people, share collections of lists with people. And certain people can come and actually add content. We don't quite have a concept of teams yet, but why did we make it? We didn't make this because we felt like we're going to do a better job than other people are doing it. There are other platforms out there that do this. It's just, this is a way for us to learn and play with technology up and down the stack. How else do we use it? Well, the actual API is used by consumers on static sites that are rendered to content delivery networks. One example is Cassandra.Link. It's a statically generated website, 100%. It runs on static files, but it's generated from the API. The data is actually also indexed onto Algolia. And so that API is managed by somebody else. And then, when people find links, they can share it. And, regardless of what's happening on the background, this website is up and running. There are also curators who can share links with a Chrome extension. So it makes it easy for our team to quickly, save and tag it with Cassandra. The next time this website is built, bam, it comes up there. Not fancy, not too complicated. It's just a basic API that stores content. I've been in the content world for almost 20 years now. This idea of statically generating websites was there 20 years ago. It's now called static site generation or static site rendering. It seems like something new, but it's really not that new. It's been around for a while. This is our current status of this whole system of knowledge that we build on top of our framework. We have a system that we didn't create. It's called Wallabag. It's a open source PHP application that uses MySQL. It has an RSS feed that then gets pushed out to MailChimp as well as our Slack groups, and it's also syndicated onto a couple of websites. Then we also have some code that takes that data, indexes it into Solr, indexes it into Algolia. We also have a couple of stateless metadata API that collect information about these URLs that we're saving, and they save that information in a Cassandra database. And the engine that runs all these processes, that's called Base. The sites to the left are still in development, but Cassandra.Link is been out. It's always going to be in development. We're going to continue improving it. And the Leaves websites they're launched, and most of the people that use it are really our team members, whereas these sites over here are meant for the public. So we decided to make a transition from doing all of this stuff on servers to becoming a serverless platform. We know how to do this stuff. We know up and down the stack, right? Every cloud orchestration tools, automation tools, infrastructure as code. And we actually do that for our clients. We help them design and build scalable global platforms using this technology. But we felt that this is where the trend is. This is where things are going to go. And there's a reason why people are going away from managing their own servers to becoming serverless. Well, first of all, if there's issues with a server, then you have to have somebody go look into it. And even if you have things like auto scaling, you have to worry about this stuff. Per service, you have to think about, okay, Cassandra is going to need these type of instances, and the node application servers are going to need that type of configuration. What are we going to do with disaster recovery? What load balances are we going to manage? You have to worry about everything, right? You have to worry about the infrastructure, this OS, and your application. And then if you have a platform that you built on top of it, you have to manage that platform as well. So when we go to serverless, we're talking about things basically becoming containers, right? So where servers can come and go, the containers can exist whenever, wherever. The containers can come and go, but then functions are even better because you have a clear separation of concern that this function is going to exist in a universal global platform to get executed by anyone, anywhere. We're not going to cover serverless functions today, but we are using containers on a serverless platform called GitPod. Another shift that happens when we go from servers to serverless is that we go from a local integrated development environment, which has its own issues, to a cloud IDE. So in a local development environment, it may be working on your computer. Even if you're using Docker locally, you have to commit your code. It goes into CI/CD. Whereas in a cloud IDE, it's much easier to collaborate with other people. it's easier to get things done. Our team did a little bit of local IDE to do this code that I'm about to show you, but most of the work has been pretty much done on Gitpod. This is where we're going. We are going to cover Astra today. We're going to cover some APIs that are built with Python and with Node that represent this layer right here. We will show you the interfaces such as the leaves interface in Angular, in React Next, as well as React Gatsby. And then in subsequent webinars, we're going to cover the rest of the stack, including using Spark for machine learning to make this knowledge smarter, to have recommendations. We're also going to cover event-based or event-sourced architectures where every interaction of saving a link to adding a tag to a link to gathering links from other streaming platforms like Twitter or other content platforms like LinkedIn or Medium through Kafka. And our goal is to have this whole ecosystem run 100% without a single server being managed by us. Why did we decide to use Astra? We wanted to focus on the features, and that's what matters right now is the usage of our platform and actually publicizing the Cassandra.Link website. And there's a couple other websites we're working on as well. As I mentioned earlier, there's a trend toward serverless that we have embraced. I think most importantly, it's because our time is valuable. We help our clients with some of their most difficult problems in relationship to building and designing and building large-scale business platforms, data analytics platforms. And even though we can do all of this work, we have limited time and capacity to do this for ourselves. So it's actually much easier if we can just offload that work. Yeah, we may be experts at Cassandra, but we don't need to manage our own Cassandra cluster for a website like this or an app like this, right? We're not in the product business, we're a services business, and this product is very low-key for what we're doing. Because we can save time managing servers, we can build faster, and we can scale faster, because that's implied. When we use a scalable platform like Astra, it's implied that we don't have to worry about the scale. If we use a scalable platform like Netlify or Vercel, we don't have to worry about that. We just need to worry on building. We just need to worry about building the software, not scaling it, and not managing the infrastructure. Some resources you can check out that relate to what I'm about to present. The Cassandra.Link is a website with arguably the best knowledge base about all things Cassandra today. Cassandra.Tools is relatively new, but it's a hand-curated list of projects on the internet that are open source, or there may be some commercial or SaaS products there as well that work with Cassandra. And not just Apache Cassandra, but DataStax, Alessandra, Astra, Cosmos Cassandra Service, Yugabyte, Scala, you name it. CQL is CQL. So check it out. To learn more about DataStax, DataStax.com, and then of course Astra.com. Astra.datastax.com is where you can sign up and create your own clusters for free. Familiar with Python or Flask, check those out. This deck will be published, so you can link to it or just Google it. And then if you're not familiar with Express or Node, you can go check those out as well. How did we do this? How did we make an API using Python and Node on top of Cassandra? Well, we used Gitpod, which is a open source, well, it's not really open source, but it uses an open source project called Gitpod. And Gitpod uses something called Thea. We'll take a look at that in a second. We use Postman, just quick testing on the REST APIs. We use Node and Express for a Node version of the REST API. We use Python and Flask for a Python version of the REST API. And we can compare the two and see, which one would be easier for you. We also have a set of tests written in Node, and as well as a small Python program that takes data and inserts it into Cassandra, just for massive or batch data ingestion. The GitHub IDE, it looks and feels like Visual Studio Code. It is not Visual. It is compatible with Visual Studio Code extensions, but it is very clear if you go to the Eclipse Thea project, this is including, that it is not Visual Studio Code, but it feels and tastes just like it. As you can see in the screenshot, we have some Python code, and because it has extensions to recognize Python, it's syntax aware, and then also has JavaScript extents. And this is from a browser. This is not running on your computer. This is coming from a browser. So before we dig deep into the code, I want to step out and show you guys the Astra interface, as well as how easy it is to get started in Gitpod. So Astra, if you go to astra.datastax.com, you're going to be able to either log in using GitHub, you're going to be able to log in using Google, or if you want, you can just make your own email-based login. I signed up for Astra before these functions were there, so mine is just based on email. And when I log in, what I'm seeing here is a workspace which, actually we can have different organizations, we can manage users and bill for each of these organizations. This is just my organization called Raul's Databases. And right now we have one database, okay? I was going to have a completely blank workspace, create a cluster, and connect to it. But it takes a little bit of time to spin up because it's basically it's a Kubernetes-based Cassandra cluster. I wanted to keep this as short as possible. Creating a new database in Astra is fairly easy. You go and you pick, when you don't have an Astra database, when you don't have your first Astra database, you can get free database just by signing up with 10 gigabytes of storage, free forever. And right now we're already using one of the free tiers. But you can easily create a cluster in GCP or Azure. You pick your region, you determine your capacity in terms of units. So a capacity is basically, one capacity unit is 500 gigabytes. So if you had 5 terabytes, you'd say 10. Let's see. I think there's a guardrail on the beta version of it. But after you pick your size, or if you're choosing the free tier, you're going to pick your database name. You're going to pick your key space name, and your key space name is what you would have inside Cassandra. So inside Cassandra, there's a concept of tables or column families, and they're basically organized in a container called a key space, right? Database name here is really just for your purposes of organizing the databases on the Astra interface. Under the hood, this is all Cassandra. Your database name, username is what you're going to use to authenticate. And this is what your code is going to use to get into it. You're also going to be using that user interface to look at your CQL in your CQL console. All right, so this is where I can log in and run my CQL queries. Oops, wrong password. Actually, I have the wrong username. And just like, any Cassandra cluster, they're very similar to the MySQL or Postgres, command prompt. You can say things like, show key spaces. Oops, describe. Sorry, I was using MySQL earlier. And it shows you the key spaces. It created this key space for me. I'll say, use the Anant network key space, and I can say describe tables, right? And it shows me which tables are here. This is the table that I had earlier. I'm gonna go ahead and drop this table. Okay. And now if I say describe tables, I no longer have that table there, right? And that's to show you that I'm starting fresh. I don't have a table there at all. All right. The other interface I wanted to get you to see is the Gitpod interface. So here we are. This is a private repository right now. We're just about ready to release this. Tomorrow we'll be ready to put it out there. We're just doing our final testing on mutation. The code actually works fairly well. But to get started with this code base, it's as easy as cloning this, going inside and following the directions to create a cluster and downloading the credentials, setting the password, and running the migrator. We're actually going to do all of that in Gitpod without even downloading code locally. So this is pretty quick because, I had already opened it earlier. Sometimes, by the way, this is a free service, so I'm not going to complain. But sometimes it takes, 30 seconds to spin up your environment. What you get when it comes up is basically, a bash terminal to do whatever you would do locally on your Mac or PC, Ubuntu. And I'm going to zoom in so you guys can see a little bit better here. And here we are, right? This is our Gitpod interface. What we have here is our structure. So we have the node code. We have the Python code. We have the code for testing. We have where we store our credentials. We have a Python importer, and we have a notebook area where we're going to drop some of the studio notebooks. And right now, we don't have any in here right now. The scratch pad will go away. It's just a place where we play around with code, the different team members. And this is Gitpod. Let's go ahead and get started. So if we take a look at the instructions, the first thing it says is, download the Secure Connect bundle. So we're going to go into our database. And here we go, download Secure Bundle. And I already have this in my desktop, and I'm going to go ahead and save it. Yes, I'm going to replace it. I'll go to my Gitpod area, and I'm just going to drag this into my credentials folder. There we go. And in my user credentials, which is what the docs tell me to do, I'm going to go ahead and update the username. So our username that we're going to use here is Anant_admin. Password is, wait for it, 1, 2, 3, 4, 5, 6. You say, wow, that is not a secure password. Why would you ever set a password to be like that? You know what? Even though that password is very insecure, you won't be able to access that cluster unless you have this special secure certificate zip file, right? I also have my cluster name. So the cluster name is basically this name right here, Anant-network, and we should be good. Let me just double check something. Yep. The code that you see here is actually a slightly more updated version of the code. So the credentials may not 100% reflect what you have there. Actually, you know what happened? I know what happened. I have not switched to the dev branch. And the way I'm going to get there is by undoing this and undoing this. And I'm going to just go to the dev branch real quick. Let's see where we're at. Here we go. This is what we were looking for. So this is still here because I uploaded it earlier. I'm going to set my username, set my password, and we're going to set the cluster name. And my key space that I had named it was called Anant-network. And the table that I want this stuff to go into will be called leaves. And once that's done, I'm going to copy and paste this command that they've given me here. And looks like it connected because it got the version number for Cassandra. It got 100 or so links out of 11,000. And it's starting to send it over. So that code, we're going to take a look at it in a second, but what it did was, if we go to our CQL console, and I'm going to do a scan, even though you're not supposed to on Cassandra. Right, that's what it added here, right? It basically, and I'm going to show you again, if I were to truncate this table, don't worry about that warning. I'll explain that at another point. There's nothing in that table right now. And when I run this code, okay, just press up. Boop. And we can go double verify in Astra what we have. 100 rows. So now we know that there's data in our Cassandra table. What we want to do next is to see if that shows up in our API. Right? We have two sets of APIs that we've created. So let's take a look at the Python one. Python API code is much simpler. And in order for the Python code to work here, we need to install the prerequisites, which I've already done, but there's three things you need to make this API run. Well, you need Python and the pip, but then you need the Cassandra driver, the requests library, and then Flask. Okay, so you're going to run Python 3. Actually, you know what? I'm going to go ahead and install the requirements again, just so that you can see how that works. They'll probably say, these are already here. Already installed, already satisfied. Yep, I already knew that. Okay, cool. So now I'm going to run the app itself. And it's using the same credentials that the importer used. Gitpod magically detects that there's a port that I've exposed here. So I'm going to go ahead and make this public. Once that's public, we can open that in a browser. And I was going to say ta-da, but it's taking its time here. And let's see, did I make it public? I believe I did make it public. Okay, that's fine. Yeah, it took a second. It's exposed. And you know what, this not found, it just means that we're not going to the right endpoint, okay? So the endpoint that we have, if we take a look at the code, is actually I'm going to close this. There we go. The endpoint for this is /API/leaves, right? So we need to put that in there. And when we do that, the data that we had imported is now available, right? And this is all the data. This is all 100 records. Probably not going to do that, right? We're probably not going to get everything, or at least not 100 at a time. So how about I figure out, you know, I want to try out one of them at a time. So I'm going to say, give me just the ID, limit 5. You know, give me 5 of these. So I'm going to take one of these numbers, 13936. And there you have a REST endpoint for reads. We're working on the writes as well, but we're going to wait until tomorrow to give you an update on that. But that's it. If you take a look at the code in Python, it's fairly straightforward. It's actually maybe a little bit easier to read in the deck here. But you know, all we do is we connect with Python. We check to see which version we have. We set the key space. And we write up. This is it, by the way. This is the whole. This is the whole endpoint. Okay. Select JSON star from killer video dot leaves. This is from before, but that's it. That's what the code does. Gets it, returns it. Done. All right. Let's take a look at the JavaScript version of the API. I'm going to go ahead and bring back the terminal. I'm going to exit out, end that API. That API is no longer running, right? And I'm going to run the node version of the code. So I'm going to go into my Astra API/leaves node. I need to follow the directions. So if I take a look at the directions here, under our directory, it says, you know, go into here and run npm install. So I'm going to run npm install. And what npm install does is it's kind of like pip, but given a JSON file, package.json, it goes and downloads all the dependencies. Unlike Python, it actually stores all of those dependencies right here in node_modules, which can get pretty big, by the way. Now, npm has installed all the packages, all 419, and I'm just going to follow the directions again. It says npm start or npm run dev. I'm in development mode, so I'm going to run npm run dev. It says it has a new API. I'm going to open it in the browser And, you know, I'm going to try the same exact endpoint that I wrote here. And it's formatted slightly differently, but you know what? Trust me, it's the same data, right? It's the same exact data. In fact, if I go to the / endpoint, I'll get all of the data that I was getting in Python. So what does the node code look like? It's not that much different. You know, it's actually very similar, right? You connect using the Cassandra client. There's some, you know, middleware code related to Express. The router, very similarly, you know, you say, hey, you know, this is my route, and select star from. So in the node version of the code, what we're doing is we're just getting the tabular data and then just returning it as JSON. So in this case, JavaScript is just JSONifying that information. It's about the same number of lines of code, right? It's not that much different. Other parts of the code, just to take a look at, we use Supertest, Mocha, and Chai. Supertest is used to just make sure that the services that we need are up and running before we run the test. Mocha is used to basically describe the test, and then Chai is used to assert to see, you know, is what we were expecting, is it what we're getting, what we were expecting? Okay. Now, before I go to the questions, I want to show you one more interface that's part of Astra, and that is the Studio. If you use DataStax Enterprise, the Studio is actually a kind of a trimmed down version of DSC Studio. And what it offers is a notebook style interface to see the data. You don't necessarily get to edit the data, but it's basically a way for you to do the same thing that I was doing in CQL, but to do it in a web-based interface. So, you know, earlier I was trying to delete some information, but I'll do the same query that I was doing earlier. So select count star from, and I'm already in the key space, so I don't have to really type that out. I can say leaves. And I'll say limit 1. I don't want to get all the data back. Here it is. I've got count. Well, actually, you know what? Limit 1 doesn't matter because we're just doing a count here. Okay. And if I want to get more, let's say all of the fields, then I'm going to do limit 1. And I can see the data in a grid. If I did 5, right? And there's actually a couple of things in here, you know, given some metadata, you can actually do some basic visualization, you know, really not useful with this type of, this is just unstructured textual information. If you had numbers, you could see pie charts and line charts. Right now, this is obviously all we're going to see is just the grid. You could also ask for this data as JSON, and this is what we were doing in the Python code. We were asking Cassandra to give us data back as JSON, right? And you wouldn't expect this. If you're not a Cassandra user, you wouldn't expect Cassandra to be able to natively return back JSON. In fact, you could just type in, you know, select JSON, right? And run it, and you get back one record. It also has an API to insert data as JSON. So whatever you were doing in Mongo or Dynamo, you can do similar things in Cassandra at higher scale and with more fault tolerance and with better data replication than you would in those other systems. Another cool feature about the DataStax Studio here is that you can look at the schema right? You can see all of the elements of what's in your system. This is the schema. And, you know, right now we have only one table that we're worrying about. There are some other tables that the sample code made. There's other features we're not using, but we will as we continue iterating on this, such as secondary indexes. What are secondary indexes? That's a way to search for information against Cassandra without having the partition key, right? Cassandra is a NoSQL database. There is also something called a search index. And a search index allows you to do wildcard queries and, you know, queries that you're used to in the relational world. And they do that under the hood using something called SASE, storage attached search index. Storage attached secondary index. We also have a concept of materialized views in Cassandra. I'm not going to get into that today, but if I wanted to have a subset of this data where I just want to expose, for example, you know, not all this information, but maybe just a preview picture and let's say the summary of the contents, I could optimize a materialized view that would be very performant. It would just be focused on returning back those two fields, right? And to round out the Astra interface, you know, what would an enterprise database be without some enterprise monitoring? Well, we have a Grafana dashboard that the folks at Astra have created for us to monitor the most common metrics that you'd care about in Cassandra. So for example, in our case, we have a free tier, we only have one node, right? There's no nodes down. We're not really doing a lot of data ingestion, so there's really not that much happening in terms of compaction. How many clients are connected? There's 2. That's because we had one importer, and then we had a Python program, and then we had a Node program. But actually, right now, it's probably this endpoint. I think it's still running. Yep, this endpoint, as well as the DataStax Studio, right? We're using the DataStax Studio to connect to that. And, you know, for the most part, once you have an Astra database up and running, the only thing that's going to get you in trouble is bad data models. And we have a whole talk about data modeling problems in Cassandra. But for the purpose of this presentation, we met our goal. We showed you how easy it was to get started with Cassandra, DataStax Astra platform. We showed you how to quickly get an API running using Node and with Python, as well as import in. And we rounded it up by showing you how the Astra interface can allow you to be fairly self-sufficient without having to have an expert helping you manage a cluster. And with that, we'll pause for questions. So if you have any questions, you can raise your hand, and Akwi will unmute you, excuse me, and we can go from there. Give you guys another 30 seconds. Okay, well, thank you everybody for joining. If you have any questions after this, please feel free to contact us. You can email solutions@anant.us. You can find me on Twitter. I probably won't respond. Go to Cassandra.Link. Go to our GitHub. You can create issues for awesome Cassandra. You can send us email. However you want to get in touch with us, let us know how we can help. And the next, looks like there's a chat. Let's see. Oh, here's a question. Can we do the same with Eclipse? So Eclipse, sure. Eclipse is just another text editor, right? So everything that I did in Gitpod here is, all I did was edit text files and run Python applications and run a Node application. you can do literally everything that I did on your own computer. Yep. And when you say Eclipse, Eclipse is a very big project, right? So Eclipse Thea is the platform that is actually used inside Gitpod, right? It's actually using Eclipse, right? It's called Eclipse Thea. But I think the Eclipse you're talking about is the grandfather Eclipse, right? Which is a desktop tool. And, you know, if you have that, you can do the same thing, right? In fact, you can see the IDEs now, there are two versions of it. There's Eclipse IDE and there's Eclipse Thea. Hopefully that answers your question. Okay. Any other questions? Okay, great, excellent. All right, guys, we'll give you back some time on your clock. Enjoy the rest of the evening, the afternoon, the morning, whatever time it is where you're at. We will do a little bit of editing with the video and get this out on the interwebs. And expect another follow-up webinar as we continue to iterate on this code. As I mentioned, we're going to be working on this code towards making a complete event-based, event-sourced, event-driven architecture on Astra, on Spark, Kafka, and eventually even serverless functions. Thank you, everybody. Have a wonderful day.